2013, paper 1, question 1. So this question, a student, he want to perform an experiment to find the value of G, the gravitational acceleration. So what he did was, he let something, let me see, an object. He let an object to fall freely from rest. That means initially the speed is 0, and then the thing is falling, and then he record the time and the distance traveled s, and then he plot t squared versus s. T squared is the time, s is the distance traveled, and then this is his data point, and he plot a best fit line, and from the best fit line he got the gradient of the line 0.204 second square meter per meter. Okay, now the question asks you to comment whether his experiment is accurate and whether it is precise. Okay, so these two concepts. Whenever you are dealing with a bunch of data and you have graph, right? Whenever you have graph and you have a bunch of data, the criteria for accuracy is the following two. First of all, you ask whether the experimental best fit line, in this case, this line, whether this best fit line match with theoretical equation. Okay, let's see. So theoretical equation, we start with this kinematic equation, and then we can simplify the equation to this, because u is 0 and acceleration is gravity. Okay, so according to this equation, when you plot t squared versus s, it should be a straight line through origin. Let's see. Yes, it is a straight line and it passed through origin. Therefore, it is a yes. I mean, as far as the best fit line, it is yes. For example, the best fit line can go wrong if the student got something like this where there's an offset. Then this offset is an systematic error. Therefore, this will no longer be accurate. Okay, so yes, and then the second criteria is whether experimental value for certain physical quantity determined from the experiment is close to the true value. Yes is also a yes. Let's see how we conclude this. First of all, we are told the gradient is 0.204, right? We also know the gradient is 2 over g from the theoretical equation. Therefore, we can write this equation 2 over g equals 0.204, and therefore g equals 9.80, which is close to the true value 9.81. Therefore, it's a yes. When I say close to this value, that means the error is less than 1%, for example. Okay, now we come to precision. The criteria for precision is pretty straightforward. That is, whether the experimental data points perfectly fall on the experimental best fit line. You see the criteria is experimental. Nothing to do with theoretical. Okay? Precision is simply about your random error, your instrument quality, and etc. So the answer is no. Why? Because the data point scattered about the best fit line. You see, it's scattered, right? If the data in front of you is something like this, then you should say yes, it's precise. But normally we say not precise. Okay? Whenever we see something like this, which is obvious. Okay, so the answer is A. That is accurate but not precise.